Good morning, Knights. Welcome back to Chemistry Online. So today we're going to be talking about compounds. We're going to continue talking about binary ionic compounds, and we're going to go a little bit more in depth with the transition metals and the polyatomic ions. Starting next class, we're going to talk about covalent compounds, but today we're going to finish up the first section. You've already answered a lot of questions regarding the transition metals, but you haven't worked with polyatomic ions yet, and today we're going to go in depth with both. And I'm also going to review a little bit. All right, so if you don't know this, definitely write it down. These are notes from last time. So valence electrons, these are the outermost electrons. So if we look at this element right here, it's got one electron in its outermost shell. That's the valence electron. You need to know what that means. Atoms, they're most stable when they have a full valence electron shell. Just know that. We've been talking about that all year. An ion is an element that either gained or lost an electron. So it's either going to have a plus charge or a minus charge. So something like lithium, it's going to have a plus charge after it loses an electron, because lithium has 3 protons, 3 electrons, and if it loses 1 electron, then it's going to have 3 protons and then 2 electrons. And if it's got 2 electrons, and if it's got more protons than electrons, then it has this positive charge. That's where the positive charge comes from. It's from having 1 more proton than an electron. But fluorine has, let me look at the periodic table because I don't have these memorized. So fluorine has 9 protons. Fluorine has 9 protons, 9 electrons, and it wants to gain an electron. So after it gains an electron, it's going to have 10 electrons and then 9 protons. And in that case, fluorine is going to have a negative charge. So anions, which are the nonmetals, they're always going to have a minus, whereas the metals are always going to have a plus after they lose their electrons. Next, we have the polyatomic ions. We talked about these last class, but today we're going to go a little bit more depth with them. So polyatomic ion, that's going to be an element, or more than one element, that have a charge. So let's say we bond lithium with fluorine. So lithium has 1 valence electron, fluorine has 1, 2, 3, 4, 5, 6, and 7. It's going to take this electron from lithium, and then in the end we're going to have a neutral charge, so a charge of 0. But let's say we bond something with something else, like let's have a lithium with an oxygen. So if you bond lithium with oxygen, oxygen has 1, 2, 3, 4, 5, 6, and it wants to gain 2 electrons. If it takes 1 electron from lithium, you're still going to have a minus charge. So this is a polyatomic ion. It's elements that are bonded together that still have a plus or a minus charge. And you're not going to need to memorize these, but I told y'all where you could find them. On the back of your periodic table, so let's pull this over here. So here's your periodic table. And on the back of your periodic table, you have a list of all the polyatomic ions that we're going to be working with this year. There are, of course, more than these, but these are the ones that you're going to be using. You're never going to be given a polyatomic ion that's not on this list. So here you can see acetate. It's got a minus charge, and there's 2 different looks for acetate. It could look like this or it could look like this. Ammonium, which is NH4+. And what all these have in common is they're all ions, which means they all have a plus or a minus charge. Plus, minus, whatever. And that's what makes them ions. And the fact that they're polyatomic, it just means that there's more than one element. So CN, 2 elements with a charge still on it. And that's it. So let's move on. All right, so here's some transition metals. So we're moving back and forth between transition metals and polyatomic ions. So iron, when it's got a +3 charge, we call it ferric. When iron has a +2 charge, it's called ferrous. So just know that elements or transition metals, when they have different charges, they're going to have different names. You're not going to need to memorize these, so don't worry too much about them. Just know that they do have different names. And instead of going with the old names, what we're going to do is we're just going to put the charge in parentheses. So iron with a +3 charge is going to have 3 Roman numerals inside a parentheses when we're working with that particular iron. So let's say we have iron bonded with a nitrogen. If we were to write out its name, it's going to say IRON, and then it's going to have the 3 and then nitride. And you worked with these on the assignment last week. Just, that's how we're going to do it. So these names do not matter to you guys. So don't worry about these. All right, so it wants us to label oxidation. We did this last time, but I'm going to do it again. So everything in group 1 is going to have a +1 oxidation or a +1 charge. Group 2 is going to be +2. Group 3 is going to, group 13 is going to be +3. Group 14 is going to be plus or minus 4. And then here we're at -3, -2, -1. And then here we have 0, which means they have 8 electrons in their outermost shell. They have no charge. All right, polyatomic ions, we already talked about these. Just know that, so here we have nitrate and then nitrite. And just know that having different numbers of different things. So here we have 3 oxygens with a nitrogen. That's a nitrate. 2 oxygens with a nitrogen. That's a nitrite. So just know that they're going to have different names. And these are listed on the polyatomic ions sheet. So here's the sheet. Here's nitrate right here. Here's nitrite right there. So you don't need to memorize these. Just know that you don't want to get a question wrong for something like this. So think of something like potassium nitrate or potassium nitrite. You're going to see both of those as your answer choices. Just know which one is correct. Just know to look at your polyatomic sheet before you choose which one is correct. Just a reminder that you have all these polyatomic ions. And we're not going to go in depth with this. We already talked about binary ionic compounds. So binary ionic compounds, those consist of metals and nonmetals, which is mostly what we worked with last time. And then a metal plus a polyatomic ion is also considered a binary ionic compound. And with binary ionic compounds, you're basically you're borrowing an electron. So the nonmetal takes an electron from the metal. That's what an ionic compound is. One element steals an electron from another one. When we're talking about covalent compounds, they're not stealing, they're sharing electrons. There's a difference, and we'll talk more about it later on. All right, so writing chemical formulas, we already talked about this. So in cases like this where, so sodium is a group 1 element, so group 1 elements have a +1 charge, and then sulfur is a group 16 element, which means it has a -2 charge. How do we do this? We're just going to crisscross. So that 2 comes over to the sodium, the 1 comes over to the sulfur, and then when you write it out, you're left with Na2S. And then when you write out its name, because it's a ionic compound, you're not going to use any numbers. It's just going to be sodium sulfide. And then here, the 3 goes over to the chlorine. So as you can see right there, 3 comes over here, 1 comes over here. You don't ever write the 1s, and then you're left with AlCl3. And then over here with the 2s and the 3s, 2 comes over here, 3 comes over here, and then you got magnesium nitride. All right, so let's write these out real quick. We might have done these last class. I don't really know if it's necessary, but let's go ahead and do it. So the 2 comes over here. So this is going to be Na2O, and then that's going to be sodium oxide. And then here we got Ca, and then you don't write the 1, and then F2. So the 2 came over here, and this is going to be calcium fluoride. And then here we got Al2Se3, and that's going to be aluminum selenide. Let's see what Se is. Yeah, it's going to be selenide. And then next one, we have a magnesium +2, oxygen +2. So they're going to switch. So the 2 comes over here, 2 comes over here. But we're going to be able to reduce them. So 2 magnesiums bonded to 2 oxygens. That's going to be MgO. So you don't need to write out the 2's because they, least common multiple of 2 is going to be 1. So MgO, that's going to be magnesium oxide. And then here we have K3P, and that's going to be potassium phosphide. And that's it with the ionic compounds. We talked about this last time. So it doesn't matter what the charge is or how many of the metal you have. You're always just going to write the metal's name. And then for the anion, which is the nonmetal, you're going to take the root of the word and you're going to add an IDE to it. So for chlorine, it's going to turn to chloride. For oxygen, it's going to turn to oxide. For fluorine, it's going to turn to fluoride. You just add an IDE after the root of the word. And that's it. That's our review, which took 11 minutes. Now let's talk about some new stuff. Not really new stuff. All right, so the names of variable ions. Just remember that they're going to require the Roman numerals. So if you don't write the Roman numerals, then we don't know how many of each element there is because of the variable ions. So here we have iron bonded with 3 chlorines. And because we know chlorine has a charge of -1, we know that we have a plus charge of +3 over here with the iron. And that's why we write the 3. If you didn't write the 3, let's say you wrote IRON 2 chloride. That would mean, so you would write Fe, and then we'd know that we have a +2 charge, and we know chlorine has a -1 charge, and then you would write Cl2, which is a completely different element than this, or different compound than that. And that's why we write the Roman numerals. That's why we write the charge of the iron, because it could be something different, and we want to specify what it is so that we know how many of each element we have. So here we have copper 1 chloride. We know chlorine has a +1 charge, and if copper has a +1 charge, that means we have 1 copper bonded with 1 chlorine. Here we have tin 4 fluoride. Fluoride has a -1 charge, and because this has a charge of 4, that means that we have 4 fluorines. That's where this 4 comes from right here. So it's very important to be sure that if you're dealing with a transition metal, you're including the Roman numeral that tells you the charge. All right, so here it wants us to figure out the charge. So here we have copper 2 chloride. So chlorine is a group 17 nonmetal, which means it's got a charge of -1. So because it has a charge of -1 and we have 2 of them, our total negative charge is going to be -2, which means because we have 1 copper, our copper is going to be a +2 charge. So when we write it out, it's going to be copper 2 chloride. And then PT, I think that's platinum. All right, so platinum. So here we got platinum 3 nitride. So and that's it. And I know this was in the assignment last time and we hadn't gone over it. Now we're going over it, so that's what we're doing. All right, complete the names of the following binary compounds. All right, so here we have iron 2 bromide. Bromine is a group 17, which means it's got a charge of -1. Because it has a charge of -1 and we have 2 of them, the iron should have a 2 charge. So here we have copper chloride. Chlorine has a -1 charge. We only have 1 copper, which means copper has to have a +1 charge. And then we're just going to put Roman numeral 1. Here we have oxygen. Oxygen is -2. We have 2 of them, which means our tin has a +4 charge. So tin, and then 4 is going to be IV, and then oxide. Iron 2 and then oxygen 3. So it's already given it to us, so all we got to do is iron and then 2 oxide. Hg is mercury. And then we don't know our charge. So sulfur. Okay, so I messed up here. Let's go back up to this one right here. So oxygen has a charge of -2. We have a total of 3 of them, so a total of -6 charge. If we have 2 irons, that means our iron has to have a +3 charge in order to bond to these oxygens. So I put a 2 here. I should have put a 3. And we make mistakes all the time, so that was just a mistake. Won't do it again. All right, so let's look over here at sulfur. Sulfur has a -2 charge, and we only have 1 of them. We have 2 of them, which means we have to have 1 mercury. Mercury has a +1 charge. That's why we need 2 of them to bond with the sulfur. So it's going to be mercury 1 sulfide. All right, write the formula. All right, so let's go ahead and write some formulas. Chromium 3 iodide. So iodine has a -1 charge, and chromium, we need 3 of them to bond with this -1, which is weird. Actually, no, it's not. That just means we have it means we have 3 iodines. So chromium is going to be Cr. Cr3, I3. No, it's just going to be Cri3. Cri3. All right, next one is tin 4 oxide. Oxygen has a -2 charge, and tin has a 4 charge, which means we're going to have 2 oxygens bonded to it. So tin is going to be, I always forget tin. Tin is SN, which are my wife's initials. Tin, and it's got a +4 charge, which means we're going to have 2 oxygens bonded to it. So SNO2. And this doesn't need to be here. Mercury 1 sulfide. So our mercury has a +1 charge. Our sulfur has a -2 charge. That means we're going to have 2 mercuries. Mercury is Hg. 2s. All right, copper 2 fluoride. Our fluorine has a -1 charge. Our copper has a +2 charge, which means we're going to have 2 fluorines. So CuF2. And that's how you're going to solve these. There's no other way to solve them. You have to put in the charges of what you know. And in this case right here, we know the charges on all the nonmetals because they're all representative elements, and the representative elements, they have stable charges that do not change. All right, now we're going to talk about tertiary ionic compounds. So tertiary just means 3 or more. So tertiary ionic compounds, they contain polyatomic ions, which I told you were coming. These are the ones from the back of the periodic table. Polyatomic ions are treated like single ions. So if it's a polyatomic ion, you treat it like a single element. But it must have parentheses when more than one is used. You'll see what I'm talking about. All right, so when naming them, you're going to write each ion, the cation first, anion second, which means you're always going to, so the positive charge, let's look at these over here. So when we're dealing with polyatomic ions, in this case, the acetate is going to be written second. It's going to be the anion because it has the negative charge. In the case of ammonium, because ammonium has a plus charge, it's going to be written first. So acetate, think of like acetate is a negative charge, which means it's going to bond with a metal. So something like sodium acetate or lithium acetate. And then ammonium has a plus charge, which means it's going to bond with an anion. So ammonium, ammonium nitrate, ammonium fluoride, ammonium chloride. And so depending on whether it has a positive or a negative charge, that tells you where in the element it's going to go. So if it's got a negative charge, it's going to go at the end. If it's got a positive charge, it's going to be in the beginning. So as you can see, all of these have a negative charge. The only one that doesn't is ammonium. So just keep that in mind. Most polyatomic ions are going to be at the end. All right, so overall charge must equal 0. And you saw how some of these have -2 charge. But that's it. Most of them are most of them are -1, but some of them are -2. So the overall charge needs to equal 0. Use parentheses to show if there's more than one particular polyatomic ion. So let me give you an example of what they're talking about here. Let's go with hydroxide. So OH is going to be a hydroxide, and OH has a -1 charge. So let's say we were bonding this this hydroxide with a calcium. So calcium has a +2 charge, and because hydroxide has a -1 charge, we're going to need 2 hydroxides to bond with this one calcium. So we're going to put the OH in parentheses, and we're going to put a 2 right here. So that's what they mean about that. Whenever you have a polyatomic ion and you have more than one of them, it needs to be placed in parentheses so that you can multiply everything inside the parentheses. Use Roman numerals to indicate the ions when it's needed. So if you have a transition metal, be sure to include the parentheses. So if we had an iron here, so Fe, and we were to write it out, we would need to include, it would be iron 2 hydroxide. All right, so let's go ahead and work with these. So first one we have is aluminum nitrate. So let's bring on this thing right here. So nitrate is going to be NO3 minus. So NO3 minus. Oops. And then aluminum, Al. If we look at the periodic table, aluminum is in group, I think 13. Yep, it's in group 13, which means it has a +3 charge. So how many nitrates are we going to need to bond to one aluminum? We're going to need 3. So we're going to put a parentheses here and then a 3 right there. So our answer is going to be AlNO3 parentheses and then a 3 on the outside. And that's aluminum nitrate. Next one, copper 2 nitrate. Let's go ahead and write out our nitrate. So it's NO3 and then copper 2, so Cu. So our copper has a +2 charge. We know that because of this 2. And our nitrate has a -1 charge. So how many are we going to need? We're going to need 2. So we're going to put a parentheses, 2 goes here. And then when we write out, it's going to be Cu NO3 2. Iron 3 hydroxide, so Fe. Our iron has a +3 charge. Our hydroxide has a -1 charge. Hydroxide, we just worked with it, so that's going to be OH. And OH has a -1 charge. So how many are we going to need? We're going to need 3 of them. So when you write it out, it's going to be Fe OH 3. Next we have tin 4 hydroxide. So tin, what was tin again? It was Sn. And it's got a +4 charge. And our hydroxide, which is OH, has a minus charge, which means we're going to need 4 of these in this case. That's going to be Sn OH4. Let's see if I'm right. All right, so I haven't worked with these in a long time. These exponents, they need to go at the bottom. That's the only thing that you got to keep in mind for this. So this just needs to be brought down to here. So I'll do that just to be consistent. In the future, I will not make this mistake again. So 3 goes down here, 2 goes down here, 3 goes down here, 4 goes down here. Let's go ahead and move on. All right, so strontium phosphate. Now we're just doing the opposite. And to answer these, we're going to need our polyatomic ion chart. So first one we're going to work with is phosphate. Here's phosphate right here. So PO4 with a 3 at the top, which means it's got a charge of -3. Let's write that out. So PO4. And what this means is we have 4 oxygens bonded to 1 phosphate, and then it's got a charge of -3. So this whole thing has a charge of -3. And let's find strontium. Strontium, I believe, is group 2. Yes, it is. So strontium has a +2 charge. And here we're just going to crisscross like we did before. So the 3 comes over to the strontium, and the 2 comes over to the PO4. So in parentheses, the 2 goes here. So then when we write it out, it's going to be SR3, and then parentheses, PO4, close parentheses, and then a 2 goes right at the bottom. That's going to be strontium phosphate. Next one we have is lithium acetate. So lithium has a +1 charge. And then acetate is going to be COH3O2. C2H3O2. And then this has a charge of -1, which means we're just going to need 1 of each. So the way this one's going to be written out is LiC2H3O2. So this is sort of a complicated looking element, and a lot of people will look at this and be confused. A lot of people will look at something like this and have a hard time figuring out that they have a polyatomic ion bonded to a single element. You're just going to need to get used to them. So most of the time, if you have more than one, it's going to be in parentheses. So usually polyatomic ions are pretty easy to identify, but sometimes, like in cases like this one right here, it's more difficult to identify, but you'll get used to it as you continue working with these. So anytime you see C2H3O2, you're going to know that's an acetate bonded to a lithium. Let's go ahead and move on. So next one we have is platinum nitrate. Platinum is going to be PT. And as we know, platinum has a variable charge, but in this case it's got a 1. So that's going to be +1. And then nitrite is going to be NO2 minus. So NO2 minus. So we're only going to need 1 of each. And I'm going to erase the charges and then just bring these closer together. So PTNO2. And then this one, also because we don't have parentheses, it's sort of weird looking, but you're just going to need to be able to identify that NO2 is going to be nitrite, sorry. Next one we have is chromium sulfate. So chromium has a +4 charge, and then sulfate is SO4 with a -2 charge. So -2, and then this is SO4. That means we're going to need 2 sulfates to bond to our chromium. Chromium is going to be Cr, and our sulfate is going to be SO4. It's going to be in parentheses, and we're going to need 2 of them. And that's it. Those are our examples. Let's see what we have on the next page. It says name the following compounds. So let's go ahead and name these. So here's our example that includes ammonium, where ammonium actually comes first. So that's going to be AMMON. So ammonium phosphite. But that's the only example where the polyatomic ion comes first. All the other examples we have, the polyatomic ion comes second. Next one we have is going to be barium hydroxide. Calcium sulfate. Oh, and another thing I want to add is you will not change the ending on, well, you will on this one, but you won't change the ending on the polyatomic ions. So let me bring them back out here. So when we talk about these, we said that we always put an IDE at the end. You put an IDE at the end if it's an element, but if it's a polyatomic ion, you're always just going to write it out as it is at the end. So acetate, you're going to put acetate. Ammonium, you're going to put ammonium. Carbonate, you're going to put carbonate. You're not going to change it to carbonites, because if you do that, you're changing you're changing the compound, and you don't want to change the compound. All right, so next one we have is going to be ClO3. That's chlorate, so chromium chlorate. Next one is iron. Actually, I made a mistake right there. Let's pull up our... All right, so we know chromium has... Well, chromium has a variable charge, but chlorate has a -1 charge, which means because we have 3 of them, we're going to need to put a 3 here. So don't forget to do that. Even the professionals forget to do that, so my bad. Let's go ahead and look at the next one. So here we have iron 3 and then PO4. PO4 is phosphate. So iron, phosphate. Phosphate has a -3 charge. So we did a crisscross here, which means our iron has a 2 charge. So this is going to be iron 2 phosphate. And that's it. So I'm going to give you an assignment today that includes polyatomic ions. Hopefully you guys will get that done before next class. And then next class, we're going to be able to move on to covalent compounds. I'll see y'all then. Have a good rest of your day.